Hello, everyone. Thank you for joining us for the fourth session on day 2 of Big Blue Button World Conference 2022. My name is Jess, and I am the moderator for this session. So this session is called Present and Future Testing in Big Blue Button. Big Blue Button spends a lot of time testing its software before each release, and there's just a lot that goes into that. And today, Maxim and Anton will be talking about an overview of future plans to expand the automated testing of Big Blue Button. So Maxim Khlobystov is an Ottawa-based software developer at Blindside Networks and has been a part of the team for almost 5 years. He's been contributing to Big Blue Button since 2014, and as a member of the HTML5 client team, he also supervises the development of automated tests for Big Blue Button. And joining him in today's presentation is Anton Barboza. Anton is a software QA tester at iMDT based in Campo Bom, Brazil. He has been contributing to Big Blue Button for a year now, developing end-to-end tests and testing new releases and bug reports. So turning it over to you guys.
Thanks for the introduction. Yeah, I think we can start. So yeah, my name is Maxim, so today's presentation is called, as mentioned, Present and Future Testing in BigBlueButton. And we spent a lot of time into testing for each release, and a lot of that actually is being automated, and a lot of that involves some kind of automated procedures and automated tests. And how we do that and what kind of tools we use for that, that's basically what we're going to talk about today. So let me start with an overview of the current testing suite that we're using in BigBlueButton. And first of all, I think it's important to recall what kind of client-side test exists out there. So of course it's unit tests. They take a specific part of the code, unit, and test it in an isolated environment inside the browser, but still inside the browser, but an isolated environment by mocking the rest of the code. Also, there are functional tests that take a couple of those unit tests, a couple of those units, a few of those parts of the code, and check the connection between them, communication between them. And from what I just described, it's easy to notice how deeply those types of tests are tied to the actual code. But there's also the third type of tests, of client-side tests, that's called the end-to-end testing, and there's also another name for that. People sometimes use and say acceptance testing. And in our efforts to test the client continuously and also before each release, we rely quite heavily on that kind of tests, where it's not that much. It's still tied to the code a little bit through selectors, but doesn't care that much about the code. And so what that means is that it treats the BigBlueButton server as a black box, and the step that it does, it starts a browser session, then usually we create a meeting on the server and join that meeting, then emulate users' behavior by doing some actions in the browser, by clicking, typing, maybe sharing video, audio, basically everything that user can do during the session, the student can do during the session. And finally, during the process and at the end of the process, we also verify the results, see how the browser, see if all the features work properly. For the server itself, it looks just like another session of BigBlueButton, another meeting. While in fact there is a testing session happening, and we are going through the features to verify that everything works properly and as expected. And from what I just described, what I just described is a workflow of the test for single users. But of course, we also like to use multiple browser sessions during the same test run. So basically, the test run looks like looks like a meeting, looks like a presentation, and the users can have different privileges, different status, different states during the session, and that way we can find some bugs that may be related to the privileges of the user. For example, this is just a very simple example, like even like a public chat. When you test the public chat, we still want to create multiple users to see if everyone gets the message, moderator, attendee, doesn't matter. If that's not happening, then we really want to catch that as soon as possible. I want to dive a bit into the history of our efforts in automated testing. Just this morning I actually looked into my commit history on GitHub and noticed that my first testing related commit was in BigBlueButton was in 2014. So that's around the time when we actually started actively developing this current Meteor-based client. So basically, what that means is that we've been developing tests since the very beginning. Of course, the test suite evolved over time quite a lot. We learned, we applied new practices, tried new frameworks, and initially, what we were doing, we were using the Selenium testing, Selenium, and when you say Selenium, developers usually think about Java right away. We didn't use Java. Everything was in JavaScript. We were using the Selenium APIs for they're written in JavaScript, such as Nightwatch.js and WebDriver.io. So yeah, it worked well. It allowed us to automate users' behavior. So Selenium allows you to create a session, browser session, join URL, and do all the things that user may do, and track the results, see the results. But at some point, we were struggling with the efforts that we were giving on the maintenance. So the main reason for that was that Selenium development involved a lot of different tooling, and those tools were developing by different people, different teams, different companies, and keeping them up to date with each other. If there's a bug if there's a bug in Selenium, you also need to make sure that your driver version also is up to date. Your browser has the proper build number. So basically, it's not that easy to maintain. So we looked around and came to and found a few tools that basically do the same thing as Selenium does, but they have a lot of tooling packaged together and available out of the box. So we looked at Puppeteer and then Playwright. We actually use both now, but mostly Playwright. And the main difference is that there are a couple of differences. Playwright is more like a testing tool. It includes a lot of testing-related tooling that you need out of the box. Like there's a test runner. You don't need to use Chest like you do for Puppeteer. And of course, big advantage of Playwright is that it supports multiple browsers really well, while Puppeteer is focusing mostly on the Chrome. So when you download Playwright, it downloads all those browsers: Chromium, Firefox, WebKit. And another thing that I wanted to mention is since the beginning of developing Playwright test, we've been following page object pattern. That's a pretty popular pattern in testing that allows you to apply some object-oriented structure into your code. So that helps with maintenance, helps with simplicity of the code, reusability, and stuff like that. We currently have 117 tests. To me, sounds like a big number, especially given that some of those tests take are pretty complex and take a lot of time to execute. So of course, naturally, you want to you want to execute them in parallel. So that's what Playwright allows us to do as well through the feature that's called worker. So you set the number of your workers, and Playwright automatically spreads the load through them. And it's especially important given that it's 117 tests, but given that there are 3 browsers. So in fact, it's actually 351 test runs. So yeah, just the brief overview of the test suite. These are the biggest testing suites. By test suite, we usually name the set of tests that are applied to a specific area. So most of the test suites are about 10 or 9 tests. That doesn't sound like a big number, but they're actually pretty complex themselves, each test. So we cover a lot of different scenarios that may happen to, for example, the chat, polling. And I also want to give an honorable mention to the stress testing. We've been working on that quite actively for the last couple of years. We are actually using partially the same tooling as we use for acceptance testing. So we use Puppeteer to save performance measurements, performance metrics each test run, so that over the long time we can actually create charts to see how the client evolves in terms of performance. By performance, I mean such things as maybe the initial client load or how long the echo test takes. So we measure some such things, and that's one scenario how we use stress testing. And another one would be just creating a really large sessions and seeing how the client performs and see where we can improve. For example, we really improved the user list a lot over the last half a year, I think, and it's really visible in a very large sessions. Yeah, I think I'll let Anton talk more about the hands-on side of things with some examples of how you can run the test on your own machine against your own BigBlueButton server.
Yeah, so let's start testing. So first of all, I will assume that you have the repository clones on your local machine, and you also have the BBB running locally or on a server. There are so many folders inside the project's directory, but the one that interests us is the BigBlueButton tests. You need to go into the Playwright folder inside that and run npm test, as we are used to doing with our projects. Just these commands should install everything you need, but I also left those 2 commands below, which we recommend you to run just to avoid any dependencies bug. This is not required, but it's also recommended by the Playwright team. So after that, we need to do one more step, which is to set up the environment variables. You just need to create a .env file in the root of this Playwright folder. You can follow the .env.template file to define those variables, or you can just create it manually. 2 of those variables are required: the BBBURL, this one, which is the basic API URL, and BBB secret, which is the same as the shared secret. The debug mode variable is not required, but for testing purpose and more detailed informations at the end of the execution, we suggest using that as well. All right, so the simplest command to run is this one, npm test or npx playwright test, with the name of the test suite if you want to specify one, or without it to run all the tests we have. We can also define which browser you want to use by adding the flag project. You will have three main browsers available to use: the Chromium, or in this case the Chrome actually, but in this case the Chromium version, Firefox, and WebKit. By default, the tests are run in headless mode, which means that it's executed just in the memory. If you want to see the Playwright performing it, you just need to add the headed flag. With that, you will be able to see the browser opening, doing the step-by-step, and closing it. The last most important flag you can use is this one to filter the tests. In this example, I'm applying this filter inside the auto test, but you can just omit this test suite name and it will filter for all of them. This is really useful when you want to run those tests related to a specific feature. You can put there, for example, audio, webcam, or chat, that all the tests with this word will be run. Okay, so now we are completely able to run the BBB test. So after running that, you will see this output containing some informations like the browser used, the file and test name, the most importantly, if the test passed or not. In this case, they both passed. Right at the end of it, there will be a suggestion of command, something really interesting, but I will talk more about later. So let's say that you, a developer, want to contribute to the project by implementing or fixing something. In the perfect world, after coding, you run the tests to make sure that everything is okay. We will continue to encourage everyone to run it locally before opening a pull request, but we also know that we shouldn't leave this as a requirement for the development workflow. With that in mind, we added this test step is in an automated way for each pull request using the GitHub Actions. This is also known as the CI, or continuous integration. This is a very famous image about the entire software cycle from planning to monitoring, especially when we are talking about process automation. We can split it into two parts: the continuous integration and continuous delivery. But let's focus just on the left part of it, which is where the tests are concerned. These steps can be used before a release or even merging of some chains. Plan and code are steps that developer does, but build and test are automatable steps. Why don't we do it this way? So this is exactly what this GitHub workflow does. If you see, these first steps are related to building stuff in the same way as we do in production. So after building everything and the dependencies are installed, all the tests with that @CI annotation will run, which are the ones referring to the main features and the most reliable tests. Okay, so now that they run automatically, how do I know that everything is okay? So it's quite simple. You just need to scroll down on your pull request and see this part with those checks. Clicking on this button, you will be redirected to this page containing so many details like the execution time of each steps and all logs. Now you click on the summary, you will see this page with two content groups: annotations and artifacts. The annotations will be the output of the test execution and will show us if all the tests passed or which test failed. The artifacts will have the downloadable files, but before going through that, let's use a better example, like this pull request with a failed test. Okay. Here it's showing us that the allow and disallow presentation download test failed and the rest of them passed. But I think you all will agree with me that sometimes this won't be enough to understand the real failure. So to see something more clearly to that, you can click on this and download it. There should be a folder called Playwright report, and inside it, uh, that one index.html file. You can just open this file in your browser, but I will give you two better options. You can use this command I showed before to host this file and open it without you getting any CORS error. But it's important to know that when you are running it without any arguments, just that command, you will it will look for the file inside the root folder, like where you are running it. Just to specify this file, you just need to add the right directory as an argument. If you are using the VS Code, you can also use that extension, which basically does the same. I use both, just depend the occasion. Okay, so when you open it, you will see something like this, pretty similar to this, which is a list of the tests run separated by their respective spec files. So up here, you can also filter by the test name or failed test, for example. Let's say that you click it on this failed test. Here, you will see the error output and the steps executed. But for those who don't develop the tests, this may not be clear enough. So if you scroll down below that, it will be possible to see this, a screenshot right at the end of the test run, and a recorded video of the entire screen for each tab that was opened, even when it's running in a headless mode. So with that, we can analyze what was done and conclude whether or not there's a bug where it was reported. So that's it. That's really what you need to know to get started with the test, to running that, to checking the output. Now you are completely able to run those tests and analyze the reports, which is really important. So now Maxim is going to talk about the future of the BBB test.
Yeah, before we go into the question period, I want to say a few words about the plans that we have for improvement to improve our testing suite, improve our testing coverage. Yeah, so first and foremost, of course, the main priority is to improve the coverage. So we believe that 117 tests is not the limit. Yeah, so we actually have a test plan on our website, published on the documentation website. There's a link in the slide. It's something that we recommend for manual testing, but when we develop automated tests, we use that as a target. We use that as a reference. So basically, the main goal is to keep up with that full list of full list of core things that require testing for each release, for example. And of course, stability of the tests, they require maintenance every time we see, especially now that it's in the CI on GitHub. Every time we see something failing, we usually jump in and investigate. That may involve moving the test into some kind of maintenance mode to skip it temporarily. And yeah, and as Anton mentioned, not every test is included in the CI. You need to add CI annotation to have it included. So, of course, we prioritize tests to include the main ones into the GitHub actions. And just a few words about the types of tests that we either already partially have or want to investigate and add to our testing suite. One example would be the visual regression testing. If you go in through the client and you want to verify the results of how it responds to your actions, and if you if you want to see if the button exists or if some menu gets open, that's pretty easy to do through the regular methods. But if you want to verify the exact look of the client, exact look of the button or of the menu, the easiest way is visual regression tests. It's heavily based on the images, so it saves the images along the way. And every time it saves the image, it compares it to the image that's been previously saved on the previous test run. So if there's a regression, it's being shown on the thing that's called heat map, where you see only the areas of the client where something has been changed. It can be just tiny thing in the UI. It could be just like some indentation within the button or something, but we want to detect such things as soon as possible, even such a small thing as that. Also, there's unit testing that I previously mentioned. That's what Playwright also allows us to do, and that's what we are going to investigate in a relatively short term. We, of course, the application is based on React, so that means that unit testing means component testing, basically. And the component is run within the browser in an isolated environment. And finally, also want to mention some API testing. Yeah, something that we've been already kind of experimenting a bit in our existing acceptance tests. There are a few calls to API that exist. We want to expand that as well. So we want to make that a part of acceptance test a little bit, as well as making a standalone API testing set. So yeah, I guess if there are any questions, that's time.
Thank you guys so much for sharing. That was all really fantastic. I'm seeing a bunch of comments in the chat saying nice work, awesome, very impressive, really interesting, stuff like that. So yeah, thank you so much for your time. We do have time for a couple of questions. And if anybody is looking to get to the next session, I did post a link to that in the chat. But if anyone has some questions for Anton and Maxim, we do have time to answer a few of those. You guys were very thorough with your presentation. So I think there might not be a lot of questions since you guys touched on so much, which is awesome.